In this video, we're going to look at section 6.4, dividing fractions. And this first problem is a really good way to motivate dividing by fractions. So remember to use, so we say A times B is A copies of B. And one way to think of division is, let this equals C. C divided by B equals A. How many copies of B are in C? So that's kind of the idea we want to use, and it's, as you can imagine, it's a lot simpler with whole numbers and integers than it is with fractions. So this is a nice way to start, okay, and we can actually extend this first problem. So Tia made 3 cakes for a guest. If each guest receives 1/5 of a cake, how many guests can Tia serve? So, again, rather than them just say, hey, I multiply stuff, I divide stuff, it's a division section, so I guess I'll divide something, okay, and they'll divide it in the wrong order. Get them to think of what this means. You are Tia, you have 3 cakes, you're making cakes in fifths, so you cut them into fifths, and you count the number of pieces. So there's 15. Okay, so then discuss, well, I had 3 cakes, wanted to see how many 1/5 were in 3 cakes, and it was 15. Okay, now here we're going to do a bunch of different types of problems, but as a classroom activity, I usually extend this and say, well, what if she gives each person 2/5 of a cake? Okay, well, this would be 1 serving, 2 servings, 3 servings, 4, 5, 6, 7 servings. Okay, so that's 7 servings, and you have 1 piece left over. Okay, now what do you do with that 1 piece? This is where things get difficult for them, because they want to say, they look at this piece and they say it's 1/5 of a cake, which it is. But what are we thinking of here? We're seeing how many 2/5 are in 3. So it's like we're using 2/5 as our unit. We're counting 2/5. Okay. Well, if we have 1/5 left over, okay, so this is what's left over. If you gave this to a person, it would be half of a serving. So this is 7 1/2 servings. Okay. 3 divided by 3/5. This one will go in nicely. 1, 2, 3, 4, 5. Okay. So getting them to count these, and I think I use different sizes when I do this activity, so you don't get a fractional amount very soon, or this soon. I want them to see some patterns first. Okay, and then using this idea and just having them develop, they'll start to see patterns like, oh, look, these multiply, and then we can end up dividing. Okay, and we're going to develop that more, but this is a way to get them to focus in on counting the divisor number of copies in the dividend. Okay, so let's see. So again, Elaine ran 6 miles this month, 3 miles a day. How many days did she run? Okay, so really getting them to visualize this. A lot of times they just want to multiply. Okay, I don't know why, but we're asking how many copies of 3/5 are in 6. So this is her whole run, and you want to count the 3/5. Okay, getting them to do this is invaluable because, again, this is really difficult for them to see. Okay, and we show them the idea of dividing fractions using common denominators. Okay, so of course, in most, or to generalize our algorithm for dividing fractions, okay, we can always reciprocate the second number and multiply. Okay, it's not always obvious to students why we do this, and you can develop that idea. Okay, but we can also show them, I mean, with multiplication, we multiply across, and we looked at why that is. We cut into the number of pieces, and we multiply by the numerator and take that many copies. So we can do the same thing dividing fractions using common denominators. Well, this is asking, if they start using this language, how many 1/2 are in 9/2? So again, using 1/2 as our unit, And let's write how many 1/2s are in 9 copies of 1/2, because that's what 9/2 is. Then you can see, well, put in the cookies. I always like to do that. How many cookies are in 9 copies of cookies? Well, there's 9. Okay. And if you haven't thought about it before, we can always divide the numerator and the denominator and get the result. But in some cases, it makes fractions in your numerator or denominator and ends up not being worth it. But it is worth looking at these cases where if we have a common denominator, or in this case, notice 18/4 divided by 3/2. Well, if we divide across, we get 6/2 or 2. Okay. The idea being, well, we could give them a common denominator. This would be 6/4. 18 divided by 6 is 3. 4 divided by 4 is 1. Okay. So when they have that common denominator, they have a common unit fraction, and you can divide the numerators. Okay, so again, it's not as streamlined because you can't use this in every case, but it actually makes sense as opposed to our standard division algorithm. Now again, you want them to understand the standard division algorithm, but it's not as intuitive as this is. Okay, here we explain why we can't always do this. So there's an example where using that method makes it work or worse. And then there's a quick example here you might want to look at. Look what happens if we find a common denominator. Okay, it ends up being you divide the numerators, and how, here's the pattern, how does that connect? Well, if we have 7/5 divided by 2/3 equals 21/10. Okay. The comparable method, that's what we found up here through the long way. Look how it, if you invert and multiply, you get the same result. Okay, and again, you can think of cutting into the same amount of pieces as the common denominator. That multiplies this numerator by the denominator and vice versa, and then it ends up inverting them. Okay, but I hope that in cases like this, they'll, rather than going through this whole process, they can see the sense in division. Okay. And here, and you'll see in Math AS, we have them do some where they actually, in all of these, they should definitely reciprocate the second fraction, or else they'll get a mess. Okay. And you'll see in Math AS, instead of just giving them this and asking for the answer, I make them, as a first step, rewrite it as a multiplication problem, and then I have them write the final simplified answer, which would be, 20/3. Okay. And the reason for this is, you probably know they don't know which fraction they're supposed to invert. Sometimes they don't invert either of them, they just change it to multiplication. So having this step in Math AS, my hopes is that it will cue them in earlier, whether if they're making this mistake, that's where the error is going wrong. Okay. And then some more application problems. Okay. Dividing mixed numbers. Again, you hope that in some of the more simple cases, so 2.5 divided by 1/2. Well, when I look at this, how many halves are in 2.5? Well, there's 2 in each whole. There's another half, so it's 5. Okay, so we want them, that's number sense. We want them to have that. Okay. But they can always, to simplify or to have a more direct process for when they get more complicated, have them use the algorithm. Okay, rewrite as an improper fraction. I also encourage them to try to make an estimate beforehand. So this is about 4 divided by 2, so this is going to be 2-ish, but a little less than 2. Okay, this is going to be about 1/3. It'll be between 0 and 1. Okay, so again, approximating and using number sense. Okay. And then finally, make some of these fractions, signed fractions, okay? And then we'll look at the order of operation. So theoretically, of course, they've learned about signed numbers and how to perform these operations, but again, they need to see it in the context of fractions. For addition and subtraction, so this 2/3 is bigger than 3/7, so the result is going to be negative. And they can just do this as if they didn't know whether it was going to be negative or positive and see their final result. So we go through these just to make sure that they can use the processes for signed numbers with fractions. And then we have some order of operation problems. Okay, and that's what we have for Unit 6. I hope this helps.